everyone, welcome to the channel. In this video, we're going to talk about shortcuts for learning p-block reactions. We already have done two parts of this video before. If you have not seen them, please make sure you pick up the link from the description below. So basically, this is part 3 of this video series, and in this video, we are going to work on the third reaction that we have listed, and that is the reaction between different metals and HNO3, nitric acid. So to understand the reaction between metals and HNO3, first of all, we need to understand different versions of HNO3 that can react. HNO3 can be dilute nitric acid, HNO3 can be concentrated nitric acid, HNO3 also can be very dilute. Sometimes you can take very dilute nitric acid also, and in sometimes you can take cold and dilute nitric acid. So there are four types of reactions that you can observe over here. Reaction of metals with the dilute HNO3, very dilute HNO3, cold and dilute HNO3, and concentrated HNO3. And also when you look at the metals, you must be knowing that the metals are, all of them are not equally reactive. The reactivity of the metals is divided. If you remember metal reactivity series that you have learned in class 10, also in class 11 during periodic classification. In metal reactivity series, hydrogen is considered as standard, and the metals are classified based on the reactivity with respect to hydrogen. So the metals which are placed above hydrogen in metal reactivity series are considered to be good reactive metals, and the metals which are placed below hydrogen in the metal reactivity series are considered to be a little low reactive metals. So now we are going to understand how this HNO3 reacts with the metals placed above hydrogen and reacts with the metals placed below hydrogen. There are two ways that we're going to work on it. So let's get started. In the next page, we are constructing a table over here to understand things better and also to be able to remember these things in an easy manner. So the first column of the table is going to be metal that we are talking about. Let us take the metals which are present above hydrogen first, which is magnesium and manganese as a set, because both of them exhibit very similar reactivity with nitric acid, followed by zinc and iron, and then we'll talk about stannum, we'll talk about plumbum, and after that the metals that I'm writing are the ones which fall below hydrogen in the reactivity series. Copper, silver, mercury, they all fall below hydrogen in the reactivity series, and then is stibbium and arsenic. So we'll be talking about these all classes of metals. Class 1 is magnesium manganese, then is zinc iron, then is stannum, then is plumbum, and all these four classes or four sets that you see here are the metals present above hydrogen in the reactivity series, and class 5 and class 6 are the metals which are present below hydrogen in the reactivity series. And at the top of the table, I'm considering very dilute nitric acid in the first column, followed by the next one is dilute nitric acid, and then the third column is concentrated nitric acid, and then the last column is cold dilute nitric acid. The reason I'm placing it at the end is all the metals cannot react with cold dilute nitric acid. There's only one reaction that we are going to look at in this category, so I placed it at the end. So now in this table, first of all, we'll see how exactly these metals react with the very dilute nitric acid, and then we'll see how exactly these metals react with the dilute nitric acid, followed by concentrated nitric acid and cold dilute nitric acid. So let me draw down the lines over here to be able to separate these reactions effectively. So now let's get started with the first one. What happens when magnesium is allowed to react with very dilute nitric acid? The reaction doesn't happen. And then dilute nitric acid, the reaction doesn't happen. Concentrated nitric acid, you don't get to see a product formation. You get to see the product being formed only when you take cold dilute nitric acid, and the product is hydrogen. Hydrogen gas is evolved when magnesium and manganese react with cold dilute nitric acid. Moving on to the second set, which is zinc and iron. Zinc and iron on reaction with very dilute nitric acid leads to formation of NH4NO3, ammonium nitrate, and with the dilute nitric acid it leads to formation of N2O, and with concentrated nitric acid it leads to formation of NO2. So in fact, any metal that you see here on reaction with concentrated nitric acid gives you NO2. So this is fixed. Let it be zinc iron or stannum or plumbum, or maybe the set of copper, or maybe the set of stibbium, it all gives you NO2. NO2 is a common metal or a common compound produced when any metal is reacting with concentrated HNO3. But there's an exception for it, and the exception is magnesium and manganese. Why is this exception? because these metals do not react with what? With any other form of nitric acid except for cold dilute nitric acid, right? And moving on to the next thing, which is stannum. Trying to react with very dilute nitric acid, the reaction doesn't happen. And if it is reacting with just dilute nitric acid, it leads to formation of NH4NO3, followed by lead. Lead does not react with very dilute nitric acid. Not only that, none of the other metals react with very dilute nitric acid. Only zinc and iron can react because of their higher reactivity. But anyway, when stannum reacted with dilute HNO3, ammonium nitrate was formed. When lead reacts with HNO3, dilute HNO3, you will have NO, nitrogen monoxide formed. And same thing happens when copper, silver and mercury is reacting as well. And over here, stannum and arsenic, because of their very low reactivity, they don't react with dilute HNO3. They only react with what? They only react with concentrated HNO3. Just to recap this in a quick manner, we are talking about how different metals react with different versions of nitric acid. Except for magnesium and manganese, no other metals react with cold dilute nitric acid, so keep that aside. On the other hand, with very dilute nitric acid, you have zinc and iron reacting, and with very dilute nitric acid, other than zinc and iron, there's nothing else that reacts. Only zinc and iron have capacity to react with very dilute nitric acid to get you ammonium nitrate. And rest of the metals that you see down the line, they do not react at all. Followed by the next one, stannum. Stannum reacts with dilute HNO3, leading to formation of the same compound that you have seen here. And on the other hand, lead reacts with dilute nitric acid to give you NO, and then so is the case with Cu, Ag and Hg as well. And in case of strontium and arsenic, there's no reaction at all. And coming to the reaction of these all metals except for magnesium and manganese with concentrated HNO3, you have NO2 being produced everywhere. This table is very, very important, and the reactions of nitric acid with metals is also important because of its exceptional behavior. The nitric acid is a special kind of acid which have capacity to act as an oxidizing agent, act as a strong oxidizing agent rather. So instead of reacting normally with metals, it behaves a little different, and it gets you different products, unexpected products. That's why the reactions of nitric acid is so very important from P block elements. I hope you could understand whatever we have discussed in this video, and in case of any doubts, please make sure you let me know your doubts in the in comment section below, and I'll see you in the next video. Until then, bye everyone.